Tuition Mobile, quality e-learning experience on the go.
Hello and welcome to the class. For our topic today, we'll be talking about matrices. Okay. Alright. A matrix is a set of real number or complex number or elements that are arranged in rows or column. Okay. The order of arrangements, matrices are arranged in rows and columns. Alright, and they take the form of a rectangle. Okay, so matrices have the form of a rectangle. A matrix have number of rows. Most times we denote the number of rows as m. Okay, and then we use n to denote the number of columns. Right. And a matrix is sometimes called to consist of m by n. Okay, we say m means rows and columns. Okay, so sometimes we call a matrix an m by n matrix. And so if the matrix have 3 rows and 2 columns, we say this is a 3-rowed matrix and having 2 columns. Right. Matrices are covered with brackets, okay, and then they look like a bow. There are various types of matrices. First of all, we'll talk about the single element matrix. Okay, we're talking about the single element matrix. Single element matrix. Alright, the single element matrix, or what we call the 1 by 1 matrix. In this matrix, there are just 1 row and 1 column. Okay, it contains single element matrix contains 1 row as well as 1 column. Okay. Alright, a single element matrix, for example, we have A. Okay, any number on its own is a single element matrix, or we can use illustration B. This is a single element matrix, or we can use illustration of 2. Okay, because this is the first row and then the first column. Don't worry, you will understand better when we go further. A matrix is of the form, a matrix most times is given, assuming I have matrix K to be equal to having elements as follows. Okay, alright, the numbers you see as the subscripts there, they are numbers denoting the row and the column, just like you have in A11. Okay, this is as good as saying AMN. Okay, A in row 1 and column 1. Okay, that's the implication. And then this one is read as A. This is a number in row 1, and then in column 2 a number in row 1, and in column 3 a number in row 1 and in column 4. And so this is the way matrices are represented. Most times you wouldn't see these numbers. Okay, these numbers are a guide for beginners, and so now you've seen them. When we apply them, don't start looking for them. I want to talk about the basic matrix operations. Basic matrix operations. Alright, in matrix we have to know the following. Number one, to multiply a single value, element matrix by an element matrix. You know what we call a single value matrix, okay? Like say A as given above, to multiply a single element matrix by a multiple element matrix. All right, the operation involved means multiplying each of the elements in the multiple matrix by the single value. For example, to multiply a single value matrix, okay, and then a multiple element matrix, example say A12, A13, A21, A22, A23, A31, A32, A33. All right, to multiply these two matrices, okay, the operation states that you multiply each of the elements by the single matrix value. Okay, this is equal to saying A times A11, and then A times A12, and then A times A13, and then A times A21, and then A times A22, and then A times A23, okay, and then A times A31, and then A times A32, okay, and then A times A33, okay. All right, we'll take an example. For example, if you are given two matrices, for example, one, multiply the following matrices. Okay, all right, you should note that in plural form, this is the plural form of matrix, but in singular form it's given as matrix. Ask matrix. So for example, multiply the following matrix, and so we are given matrices like 4, 7, 6, and then 2, 3, 1. Matrix A to be equal to this, and then matrix B to be equal to a single value matrix, say 2. Okay, so A times B will be equal to 2, matrix 2 times 4, 7, 6, 2, 3, 1. Okay, so what we do here is multiply each matrix element by 2. You have 8, 14, 12, you have 4, you have 6, you have 2. All right, and so this is illustrating the example above. And then the other condition for multiplying matrices, number 2, it states that when two matrices, okay, two multiple matrices are to be multiplied, the number of columns in the first matrix must be equal to the number of rows in the second matrix. Okay, if you want to multiply two multiple matrices, okay, matrices that are having elements greater than 1, okay, when two non-single matrices are multiplied, non-single matrices are multiplied, okay, these conditions must hold. The first condition states that the number of rows of one matrix must be equal to the number of columns of the other matrix. Number of column of the other matrix. Okay, this is matrix. And so the second condition there states that for you to multiply, you use the row of one matrix, use the row of one matrix to multiply the column, of the other matrix. The column, to multiply the column of the other matrix. Alright, and so we use examples 2 to illustrate this. And so example 2, we have 4.4 matrix 4 7 6 2 3 having elements 1 to be equal to A, and then matrix B is equal to 8 5 and 9. And so for multiplication to take place, just like I said, the row of one matrix must be equal to the column of the other matrix, and so therefore we can say that A times B is equal to 8 5 9 times 4 7 6 2 3 1. Alright, the multiplication goes this way. This matrix multiplies this. Alright, and so let's take, for example, we have 8 5 9. Okay, the first multiplication there is as follows. You have for the first column you have 8 times 4 plus 5 times 7 and plus 9 times 6. Okay, and then for the second column you have 8 times 2. Okay, and then you have plus 5 times 3 and plus 9 times 1. Alright, okay, this is equal to 8 times 4 gives 32 plus 5 times 7 35 plus 9 times 6, which gives 54, right? 64. And then 8 times 2 is 16, 5 times 3 is 15, and 9 times 1 is 9. This gives 54. Okay, so we add them, and when we add them on this row we will have 35 plus 32 plus 54 gives 121, and then 40. Alright, so this is our matrix. Now what happens when you multiply two matrices? Alright, let's look at this. Use this matrix as a typical example and find out what happened with this matrix. Is that we had a 2-row matrix and 3 columns. Okay, 2 row and 3 columns, 2 row 3 columns being multiplied by a 3-column matrix and a 3-row matrix and 1 column. Alright, so you find out that 3 cancels 3 and then it gives you a 2 by 1 matrix. Okay, that is why we have 2 row and 1 column. Okay, this is what happens in the row and column. So the number of rows, the ones that become identical, cancels out, and you are left with this is row and this is column. We will as well consider squaring of matrices. Squaring matrices. Alright, for a matrix to be squared, it must have equal number of rows and column. Okay, for a matrix to be squared, it must have equal number of rows and column. So it's either it's a 3 by 3 matrix or it's a 2 by 2 matrix. Okay, but let's use a 2 by 2 matrix. For example, the condition here states that it must have equal number of rows and columns. Alright, and for instance we have 2 4 example, we have the matrix 2 4 and 3 2. Okay, does it have equal number of row? Yes. Does the number of row equal the number of column? Yes, because we have 2 rows and we have 2 columns too, and so we can square this matrix. If we say this matrix is matrix A, therefore A squared will be equal to 2 4 3 2 and what, 2 4 3 2. Okay, which is also as good as saying A squared of this is squaring this. Alright, so the same thing that happens with the matrix multiplication, row goes to column. Alright, and so we have 2 times 2 plus 4 times 3. Okay, for the first row and the first column here, and then for the first row and the second column we have 2 times 4. Alright, plus 4 times 2. Okay, and then for the next row that goes into this first, and you have 3 times 2 plus 2 times 3. Okay, and then for the other side you have 3 times 4 plus 2 times 2. Fine. And so we have 2 times 4 is 8 plus 3 times 4 is 12. 2 times 4 is 8. 4 times 2 is 8 2, and then 3 times 2 is 6. 2 times 3 is 6 2, and then 3 times 4 is 12, and 2 times 2 is 4. Fine. Alright, squaring this matrix will be equal to 8 plus 12 gives 20, 8 plus 8 gives 16, 6 plus 6 gives 12, and 12 plus 4 gives 16. Okay, so therefore this is the square root of this matrix. Then we shall talk of addition of matrices in added. Addition of matrices. Alright, under addition of matrices, matrices can only be added if they have equal number of rows and columns. Okay, if they have, once they have equal number of rows and columns, okay, two matrices can be added if they have equal numbers of rows and columns. Okay, these are the only conditions that can help us in adding two matrices together. Alright, so once they have equal number of rows and columns, we can add them together. We can take examples like this. Example 1. Alright, we have two matrices. We have the matrix A equal to 4 7 and 2, B A. Alright, good. And then we have matrix B equal to 2 7 6 3 1 5. Okay, so how do we find A plus B will be equal to adding elements together, elements in the matrices together. Okay, and B is equal to 2 7 6 3 1 5. A plus B will be equal to 4 plus 2, 7 plus 7, 6 plus 2, 6 plus 3, 9 plus 1, and 5 plus 5. These are done by each element, mapping onto the other, adding together. And so 4 plus 2 is 8, 7 plus 7 is 14, 6 plus 2 is 8. Right, sorry, 4 plus 2 is 6. We'll correct this. And then 6 plus 3 is 9, 9 plus 1 is 10, 5 plus 5 is 10. So this is the matrix we have. 4 plus 2 is 6. So we have a plus b to be equal to matrix 6, 14, 8, 9, 10, 10. Fine. Alright, after addition of matrices, we want to talk about the transpose of a matrix. The transpose of a matrix. Transpose. Okay. If the rows and column of the matrix are interchangeable, alright, the matrix is said to be transposable, or the matrix can be transposed. Okay, hence the first row becomes the first column, and the second row becomes the first row. Alright, look at what we are saying in this sense. Okay, assuming we are given a matrix, for example. Okay, you are given a matrix A, example 1A is equal to 4, 6, 7, 9, and 2, 5. All right, the transpose of a matrix is denoted as matrix transpose with a small t on top. Okay, the transpose of A transpose is making the rows become the column. These are my rows, so I transfer them to 4 and 6, and this column changes to 7 and 9, and this changes to 2 and 5. So I have the matrix transpose as this. Okay, you can use several other examples, but because of time, we will just manage just one example. Symmetric square matrices. Let's talk about symmetric square matrices. Symmetric square matrices. Okay, a symmetric square matrix is a matrix whose transpose is equal to the original matrix. A matrix whose transpose is the same as the given matrix, given matrix. Okay, so we take, for instance, there are matrices like that, such that Aij is equal to Aji. Okay, you know, Ij stands for row and column is equal to column and row. Okay, all right, so for instance, we have a matrix A. We have this matrix 1 to 5, 1 to 5, 2, 8, 9, and 5, 9, 4. Okay, so let's try to transpose this matrix. A transpose will be equal to, let's try to transpose, taking this as the row, and this becomes 1 to 5. Taking this as the column, this becomes 2, 8, 9, and then taking this as the last row, and then we'll have 5, 9, 4. Okay, is it the same thing with the previous matrix? Yes, this is 1 to 5, 1 to 5. This is 1 to 2, 8, 9, and this is 2, 8, 9, 2. This is 5, 9, 4, and this is 5, 9, 4, 2. So you find out that matrices like this are not affected by transpose. Okay. We'll talk about skew symmetric matrices. Skew symmetric. Please take note of these properties because we shall be applying them. Skew symmetric matrices. Okay, a matrix is said to be skew symmetric if the transpose, if the matrix is equal to the negative of its transpose. Okay, or if the transpose of the matrix is negative, the matrix. Okay, we are saying that if we have a matrix A, each transpose will be minus A. Okay, transpose will give you minus A negative values of, but all right, so for example, if we have this matrix, for example, we have this matrix where we have 0 minus 2 and minus 5 and 2 0 minus 9, okay, 5 9 and 0. Okay, if you transpose this matrix, if A is equal to this, then A transpose will be equal to 0 2 5. That's the first row coming as the first column, and then the second row coming as the second column, minus 2 0 and 9, and then the third row coming as the third column, minus 5 minus 9 and 0. Okay, you find out that in the two matrices, all the parts that we are positive on this matrix are non-negative on this matrix. Okay, we had here to be 2, here is minus 2, and all the parts that are negative are now positive on this matrix, and you can see it from these illustrations. Look at the elements very well. Okay, we also will define a unit matrix. A unit matrix is defined as a matrix in which the leading elements on the diagonal are 1 and the other elements are 0. Okay, all right, so the part where we call a diagonal is the part that divides the matrix into two triangles. Okay, this is, for instance, this is the part we call the diagonal of a matrix. Fine. And so we are saying that if the leading element on the matrix, okay, or if the elements on the diagonal are just made up of ones, okay, and other elements are zeros, and other elements are zeros, okay, then the matrix is a unit matrix. Then matrix is a unit matrix. For example, if you have a matrix of this form, where you have 1 0 0 0 1 0 0 0 1, okay, you find out that diagonal elements are just 1. Okay, A is equal to this. It could as well be in the form of a 2 by 2 matrix, where you have a matrix with 2 rows and 2 columns, and then you have 1 0 and 0 1. Diagonal elements are ones. Okay, we call them a unit matrix. Okay, and something you have to note about the unit matrix: it is equal to the other matrix. It multiplies. We are saying that a unit matrix is denoted by okay, this is the symbol for a unit matrix. Okay, is equal to I. All right, so we are saying that a unit matrix times any other matrix will give you that same matrix. That is, a unit matrix times matrix A is equal to A. Okay, so suppose we have I to be equal to 1 0 and 0 1, and then we are given A to be equal to 2 4 and then 3 5, right? Okay, for example, let us check this out and find out whether I times A is equal to A. All right, that means therefore I times A is equal to 1 0 1 0 1, okay, times 2 4 3 5, right? And so we have, for the first column, multiplying this, you have 2 times 1 and then plus 3 times 0, okay, and then we have 4 times 1 plus 5 times 0, okay, and then for the second row, this going into this, you have 0 times 2 plus 3 times 1, and then this going into this, we have 0 times 4 plus 1 times 5. Fine. Okay, this gives us 1, 2 plus 0, this gives 4 plus 0, and this gives 0 0 plus 3, and this gives 0 plus 5, okay, which is equal to 2, 4, 3, and 5. Okay, so it's our outcome the same as A? Yes, so this holds. So therefore you can conclude that I times A is equal to A. Alright, and then at this point we have talked about the various properties of a matrix, and so in our next class we'll be talking about higher properties, and then going to computations of a matrix. And at this time it's goodbye to you till we meet in the next class. Bye.